The Pythagorean theorem states that if you are given a right triangle and A and B are the legs of the triangle, the legs are identified as being the sides that form your right angle, and C being the hypotenuse of the triangle. Also, you should note that C, the hypotenuse, is always the longest side of the right triangle. Then A squared plus B squared is equal to C squared. You can use this to find the length of any side of a right triangle if you're given two of them. So, for example, if we're given that two legs are equal to 3 and 4, then you can calculate the measure of the hypotenuse by substituting into the Pythagorean theorem A squared plus B squared equals C squared. So you have A being the length of one of the legs. It does not matter which one you put for A and which one for B. What's important is that A and B are the legs, or in other words, the sides that make up the right triangle, the right angle of the right triangle. B would be 4 in this case, and then you're solving for C. You multiply 3 times 3 is 9, and 4 times 4 is 16. Remember, this is squared, not times 2. And that is equal to C squared. 9 plus 16 would be 25, and that would be C squared. Since you're talking about the length of the hypotenuse, you know that C will only be positive. So you take the principal square root of both sides, and realizing that it's only going to be positive, C squared will be the positive instead of the absolute value of C. It'll just be C is equal to 5, because we're not interested in the negative value that C could be. Sometimes you may be given the leg and a hypotenuse. In other words, you may be given the C value and either A or B. So this could either be A or B, and this would be C, of course. So in the Pythagorean theorem again, you would just substitute accordingly. So for example, if you're given the measures for a leg of 5 and the hypotenuse of 13, either one, A or B, just since I'll show you using B for 5. It does not matter, again, which one you substitute, as long as it's A or B. C being 13 would be 13 squared. So you solve this equation. A squared plus 25 is equal to 169. Like any other equation you want to solve, subtract 25 from both sides, and you would get A squared equals 144. Again, we're looking for the measure of the length of a side of a leg of a right triangle. So you take the principal square root, and so A, since it's going to be positive, is going to be 12. And that's the way you solve for the length of a missing side. Now, sometimes you can determine if it is a triple, if three numbers are a triple. The three numbers, for example, a Pythagorean triple, in this case would be the side 3, 4, and we found it 5. So a Pythagorean triple, using this first example, would be 3, 4, 5. That's a special kind of right triangle known as the 3, 4, 5. Now, the one that we just did here would be considered a 5, 12, 13 triple. In other words, it would form a right triangle if we had lengths of sides for that. You can determine if a triangle is in fact a triple, or some sides are equal to a Pythagorean triple. To determine if other lengths are Pythagorean triples, we can use the numbers 6, 8, and 10. If it is a Pythagorean triple, then A squared plus B squared should equal C squared. if we have this, a squared would have to be one of the smaller ones. We'll use 6. B squared would have to be another one of the smaller ones. And C squared would have to be the longest side since C represents the hypotenuse. If we calculate this and it does turn out to be equal, then this would be considered a Pythagorean triple. If it wasn't, then it would not be a Pythagorean triple. But in this case, you notice it does check that 100 is equal to 100. So 6, 8, and 10 would be considered a Pythagorean triple. Now, example of one that does not. For example, if we use 5, 4, and 6, then we could substitute a squared plus b squared equals c squared. 5 is a squared, 4 being b squared, and c being 6. We have 25 plus 16, and is that equal to 36? Well, that is 41. Well, since 41 is not equal to 36, this 5, 4, and 6 are not Pythagorean triple. And that's how you determine Pythagorean triples.